Section 2.4, Over-Permissive Configurations, when AI gives everything the keys to everything. AI coding agents consistently produce configurations that are wide open by default. These are not code logic bugs. They are settings that grant too much access to too many callers, violating a foundational security principle called the principle of least privilege. The principle states that every component, whether a user, a service, a database role, or a cloud resource, should have only the minimum permissions it needs to do its job. Nothing more. A related concept is blast radius. The scope of damage a security incident can cause is directly proportional to the permissions that were granted. On the left, you see wildcard permissions, represented by a star. When a credential with wildcard access is compromised, the entire system is at risk. On the right, least privilege means damage is contained to a single narrow scope. The research numbers are alarming. Vericode's 2025 benchmark found that AI-generated code introduces 2.74 times more vulnerabilities than human-written code. And Apiro research found 322% more privilege escalation paths in AI-assisted code bases. Over-permissive configurations are a major contributor to both of these statistics. Why does AI default to permissive settings? The root cause is in its training data. Introductory tutorials prioritize getting things working. A tutorial showing you how to set up a CORS policy doesn't want to interrupt its narrative with a discussion of allowed origins, so it uses a wildcard. A tutorial on IAM policies uses action star because it avoids explaining individual permission names. Look at the pattern. Express tutorials use CORS with no options, which produces Wildcard CORS. AWS Quick Starts use Action Star, leading to overprivileged IAM. S3 examples use ACL public read, creating public buckets. Docker tutorials bind to 0.0.0.0, exposing databases. These permissive patterns appear so often in beginner and intermediate tutorials that they make up the majority of what AI has learned. When an AI generates a configuration, it reproduces the most common pattern it has seen, which is the one that requires the least explanation. The statistics we just saw confirm this. On top of the 2.74 times more vulnerabilities and 322% more privilege escalation paths, Vericode also found that 45% of AI-generated configurations fail security review outright. Over-permissive defaults are a major reason why. Let's look at the 4 most common over-permissive patterns AI produces and how to fix each one. Pattern 1, Wildcard CORS origins. This is CWE 942, high severity. CORS, or Cross-Origin Resource Sharing, is a browser security mechanism that controls which websites are allowed to make requests to your API from the user's browser. On the left is what AI typically generates, importing the CORS package and calling app.useCORS with no options. This is equivalent to setting access control allow origin to star, meaning any website on the internet can make requests to your API. On the right is the secure version. You define an explicit allow list of origins, like your own domain and local host for development, and pass that to the CORS middleware. Keep the list of allowed origins in an environment variable, not hard-coded. Why does AI do this? Most Express tutorials add CORS as middleware with no configuration. It's the quickest path to working, and that makes it the dominant pattern in training data. Here's the important nuance. You might think that combining a wildcard with credentials true is safe because browsers block that combination, and they do for cookies. But for token-based authentication, where JavaScript attaches a token in the authorization header, the browser's protection never kicks in. Any website can silently make authenticated requests as the logged-in user. This enables cross-site request forgery, data exfiltration, and silent account compromise. Pattern 2, Wildcard IAM Policies. This is CWE 269, high severity. IAM, or Identity and Access Management, is the cloud permission system that controls what actions each service account can perform. On the left is what AI generates, an IAM policy with action star and resource star. This grants permission to do anything on any resource in the entire cloud account. On the right is the secure version. You list only the exact actions the role needs, like S3 get object and S3 put object, and scope the resource to a specific ARN, like a single S3 bucket. AI does this because AWS Quick Start guides use ActionStar to avoid permission errors during development. It reproduces the most common pattern from its training data. The impact is devastating. If a service with a Wildcard IAM policy is compromised through a code vulnerability, prompt injection in an AI agent, or leaked credentials, the attacker inherits every permission that policy grants. That means full control, reading all data, deleting infrastructure, spinning up resources, and creating new credentials for persistent access even after the initial breach is fixed. Wildcard policies in CI/CD pipelines are also a common supply chain attack vector, where one compromised pipeline step becomes a full account takeover. Use AWS IAM Access Analyzer to identify what actions a role actually uses and reduce overly broad policies to only what is needed. Pattern 3. Public S3 buckets. This is CWE 732, high severity. On the left, AI generates an S3 bucket without disabling public access, then uploads files with the ACL set to public read. This means every file in the bucket is accessible to anyone on the internet who knows or can guess the URL. On the right is the secure version. You enable all 4 block public access settings: block public ACLs, ignore public ACLs, block public policy, and restrict public buckets. Then you use pre-signed URLs to grant temporary, time-limited access to specific files. Public S3 buckets are a consistent source of real-world data breaches. 4 major airports had over 1.5 million employee files exposed, including passport scans and personal information. Fortune 500 companies have leaked millions of customer records. And automated bucket scanners find and index exposed content within hours of it appearing online. Once discovered, the exposure is effectively permanent. Why does AI do this? Much of its training data predates the block public access feature, which AWS added in 2018. AI reproduces the older, simpler pattern. The fix is to enable all 4 block public access settings at the account level, so they apply to every bucket automatically. And always use pre-signed URLs instead of making anything public. Pattern 4. Database bound to 0.0.0.0. This is CWE 923, high severity. On the left, the PostgreSQL configuration sets listen addresses to 0.0.0.0, which means it accepts connections from any IP address, including the public internet. In Docker Compose, the ports mapping 5432 to 5432 maps to 0.0.0.0 on the host by default, making the database port reachable from outside. On the right is the secure version. You bind to localhost only, and in Docker, you simply remove the ports section entirely. The application container can still reach the database through Docker's internal network by hostname. No port needs to be exposed to the outside world. AI does this because Docker tutorials use 0.0.0.0 for convenience during local development. It copies this without understanding the network topology or security implications. Those same configurations often get deployed to production unchanged. The impact is immediate and severe. Automated scanners like Shodan and Census find exposed databases within minutes of deployment. Default credentials, Postgres/Postgres, root with no password, are tried first, and they often succeed on AI-generated setups because the same AI that wrote the binding also wrote the credentials. Direct database access bypasses the entire application layer, meaning no rate limiting, no security checks, and the ability to exfiltrate everything at once without triggering any application-level monitoring. Let's visualize why this matters by looking at the blast radius after a security incident. Whether the incident is a stolen credential, a prompt injection attack, or a compromised dependency, the damage depends entirely on the permissions that were granted. On the left, with wildcard permissions, the attacker can do everything: delete any database, read all S3 buckets, create backdoor admin users, spin up cloud infrastructure, and access all secrets and keys. This is full account compromise. On the right, with least privilege, the same security incident is contained. If the credential could only read files from one uploads folder, that's all the attacker gets. The blast radius is minimal. The lesson is simple. The scope of damage is directly proportional to the permissions granted. A credential with ActionStar gives attackers full control. A credential scoped to one folder causes minimal harm. Every wildcard permission you leave in place is a bet that nothing will ever go wrong. Here's your configuration checklist to review after every AI coding session. For CORS, AI generates CORS with no options or access control allow origin star. Change it to an explicit origin allow list with specific domains. For IAM, AI generates action star, resource star. Change it to a named action list scoped to specific resource ARNs. For S3, AI skips the public access block configuration and uses ACL public read. Change it to all 4 block public access settings enabled with pre-signed URLs for file access. For databases, AI generates listen addresses equals 0.0.0.0 or exposes ports in Docker. Change it to bind to localhost and remove Docker port mappings for databases entirely. The same principle applies to all 4. Identify the smallest set of callers and actions that actually need access and configure exactly that. Everything else should be denied by default. Remember, least privilege by default. Every wildcard permission is a bet that nothing will go wrong. Replace star with named scope permissions. AI will not do this for you. Next up, Section 2.5, Deprecated Libraries and Slop Squatting. For more details, visit www.wisebuilder.dev.